things beginning with standard solutions. So standard solution, a solution whose concentration is accurately known. This is as simple as weighing out a known amount of solute, adding water up until a particular measured point, and then bam, you know exactly how much is in there because you can take that mass and convert to moles, and then you can divide the moles by the number of liters that are in there, and there you know the solution's concentration. So this is a standard solution. Why do we mention this? Well, this is a piece of vocabulary describing one of the things that we work with in chemistry. You make a solution of a standard known concentration, and then you can talk about, first of all, how many grams of something you need to make that solution, and later we can talk about what happens when you water it down. So let's start with, okay, how do you make a solution where you want a certain amount of a certain concentration? How do you actually make it? So, as always, you start by writing down the given of one of these calculations. Wait, you've got two givens, so what do? Let's look at the process of what we did here. I'll put the whole thing up to begin with. So what are we looking at here? It asks how many grams, so notice how our final answer is a certain number of grams. Okay, so that's where we're going. So what is all this? What it is we are saying we're taking these two givens and using them to get to a final answer of grams. So look what we did. We said, all right, 1.30 liters and 0.200 molar. And so it's asking how many grams of solid potassium dichromate do you need to make this many liters of this concentration solution. So we take the number of liters. Notice when we do this, we're using the fact that these liters cancel to give us an answer in moles. So our big picture is we are finding how many moles of potassium dichromate are in the solution, because when we take the moles, we can convert it to the grams using the molar mass. So that is essentially what has happened here. The liters and the molarity are used so that liters cancel liters to give moles in the answer, and we find the number of moles. And then we take that number of moles and use the molar mass from the periodic table, 2 potassiums, 2 chromiums, and 7 oxygens, add up to make this molar mass right here. And then we take the number of moles and the molar mass and use that to convert the moles to grams. And so that's how we got to the final answer of grams right there. So having mentioned that, let's talk about what else can happen when you're doing solutions. So aside from making them, you can start with a concentrated solution that you would start with, like where you keep it in a stock room, and you can water it down to what you need. And so the question is, what happens when you add water to a chemical solution? And this is the word dilution, describes what happens when you add water to a chemical solution. Now look at what it's saying. Okay, so you're watering it down if you add water. You are changing the volume. And obviously, if you change the volume, you're going to change the concentration. If you add water, think like orange juice or apple juice or something. If you add water, it doesn't taste the same because it's watered down. Likewise, any solution is the same thing. It's watered down because there's less concentration. So concentration changes, volume changes. But when you add water, you're not going to create or destroy the molecule that's dissolved in there. So that's why the number of moles will remain constant. We're talking number of moles of solute will not change. It's just being spread out amongst more and more water that's been added. So that's the idea here of why we say that adding water to solution will change the number, or the number of liters, the volume. It will change the concentration, but it will not change the number of moles. Okay, so if we're going to dilute something, let's do some calculations for how that would work. Here is a question. Suppose you want to prepare 500 milliliters of a 1.00 molar solution of acetic acid from a 17.5 molar stock solution. What volume of stock solution do you need? Okay, so in other words, it's saying you start with this molarity and you want to end up with this molarity and you want to make this much. How many milliliters of this original solution do you need? That's what it's asking for. Wait, it doesn't say how many milliliters, it just says what volume. Well, okay, volume. Since it doesn't specify what unit to use, I look here and I notice the only volume unit given is milliliters. So like always, if given no further instructions, we will always respond with the same unit given. So we will answer using milliliters. There are two ways to solve this question. One of them is a bit longer, but it's nice and universal and works for everything. The second one is shorter, but requires you to memorize an equation. I'll actually show you the second one first, and then I'll come back to the first way. So this is the first way of doing it, and I'll come back to this. Here we go, the second way of doing it. And I picked this because it is popular, but the one downside is you do have to memorize an equation for this. More specifically, the equation you have to memorize is this. And I think this pen is dying on me, so let me try a different one. Just, even though I'm sure the viewer could easily see that, nonetheless, just to make it extra super duper clear, M1V1 equals M2V2. Okay, more specifically, molarity 1 times times volume 1 equals molarity 2 times volume 2. So, this equation, we use this to solve the question. Now, which one is molarity 1? Which one is molarity 2? That actually can be important. So let's look at what the solution looks like for this particular question. Let me get this out of here. So what I've done here is I've identified these, and you as the viewer, when you're taking this on a quiz or a test, you are certainly highly encouraged to do this too. Like, go to the original question and pick out which one's M1, which one's V1, which one's M2, which one's V2. I'll do that here. And it actually is important which one's M1, which one's M2, which one's V1, which one's V2. Because number 1 generally means where you start, and number 2 generally means where you end. So number 1 is going to mean the stock solution you started with. That's why it's number 1. You started with it. So 17.5 molar stock solution, that's M1, because you start with a stock solution. What volume of the stock solution you need, that volume is going to be volume 1. You end up making your diluted solution. This is the volume, so this will be volume 2. You end up making the solution having this concentration, so this will be M2. Okay, that's the reason why I pick what we do. Now, honestly, if you were to pick V2 and make this M2, make this V1, make this M1, it would work, but we want consistency, and people mess this question up year after year because they get confused, and they'll call like this M1 and they'll call this V2, like they're not consistent. So we need to be consistent, and the most consistent way I can think of is whatever you start with is number 1 and whatever you end with is number 2. So having mentioned that, that's why these were identified what they are, is because this is the stock solution concentration, stock solution volume, diluted solution concentration, diluted solution volume. You then rearrange the equation to solve for this. Now wait, how did that happen? M1V1 equals M2V2. That's your original equation. On a test, always write the original equation that you're beginning with. If you're solving for V1, that means you need to get V1 by itself, so we divide both sides by M1 so that V1 can be left by itself. So it says V1 equals M2 V2 over M1. In fact, since I divided both sides by M1 so that it can cancel out, and if it cancels out, it goes away, and so you wind up with this, and this, hopefully it's clear, is the same thing as this. M2 V2 divided by M1, M2 times V2 divided by M1. Okay, this is this. Hopefully that's clear. Always show your work rearranging the equation with variables only, no numbers. That is the biggest mistake people make, is they try to rearrange the equation with numbers in it. Do not do that. Variables only. After you rearrange, then you can put in numbers, but only after you are done rearranging the equation and have shown how you rearrange the equation in your work. Now, the nice thing about this is, usually we have to convert to liters, because anytime we're talking molarity, that's moles per liter. So if it's not liters, it's got to be converted to liters. But if you're using the equation, that actually is not necessary. Because, check this out, when you plug it in, the M2 is 1.00 molar, the V2 is 500 milliliters, whatever, right? You can see where this comes here from here. You plug in all the numbers, we're going to find molarity cancels molarity to leave milliliters, which means the answer is going to have units of milliliter. So when you're using the equation, as long as like the two units as long as the units are consistent, you're not going to have any need to do any conversions. So it's just you plug in what you get, and as long as things cancel right, you'll be good. In this case, it spits out 28.6 milliliters, which is the answer. Though that being said, this is a really bad example. It needs to say Well, milliliters of stock solution. And of course, don't forget to box your answer. Notice also 3 sig figs, 3 sig figs, 3 sig figs, and 3 sig figs. So we were watching significant figures when we rounded this answer up. So that should take care of it. This is basically what you do when you are dealing with solving a dilution question with an equation. Okay, and again, how do you know it's a dilution question? Because you start with one concentration and end with a different concentration. Or in some cases, you might be solving for concentration, you might start with one volume and end with a different volume. So that was the way you do that, and this is another different example question. Let's go back and look at what is another way. I did say there's 2 ways to solve this question. So let's do that. To emphasize, when I say there's 2 ways to solve the question, they get the same answer. They are both completely valid. You can use either one on the test. So just to emphasize that point, here's the other way I'm about to show you, and notice how you went up with the same answer, 28.6 milliliters. So what happened here then? How did we get to that point? We say, okay, if you don't want to memorize an equation, we just need to reason our way through this. Again, we would start, we would start by looking at the question, you read it through, you say, I need to make this many milliliters of this concentration solution starting from this stock solution, and it's asking how many milliliters of this am I going to need, because remember, it says what volume, and you always reply with the same units given unless told otherwise, and it doesn't tell you otherwise. So what we do here is we say, okay, if we're not going to memorize any equations, then we're going to say, fine then, you have to turn, if it isn't milliliters, sorry, if it isn't liters, you have to turn it to liters, and that's our first step. Because molarity is moles per liter, so if it isn't liters, it needs to become liters. Otherwise, you can't do any conversions or calculations. So change this to liters first. Then we're going to say, okay, remember that when you water something down, the number of moles doesn't change. It's the one thing that stays constant. So we're going to find out how many moles are in the final solution, because it should be the same number of moles as the beginning solution. So find out how many moles are in here. So that's why we take this, convert it to liters, and we do what we need to do with this in order for liters to cancel liters. In this case, it's multiplying, but we do whatever it takes for liters to cancel liters to give moles. We find out how many moles are at the solution at the end, because it's the same number of moles that there were at the beginning. And we say, okay, fine. How many milliliters of this have the same moles as this many milliliters of this? So that's what this is. So we say, all right, that many moles, and then we take the concentration, which is moles per liter. Remember, molarity is moles per liter. In this case, what we did is we flipped it upside down so that moles can cancel moles, leaving liters behind. So I just said, all right, fine. Let's flip this around to be liters on top and moles on bottom. And if it's 17.5 moles per liter, this is moles per liter right here. If we flip it upside down, now instead of 17.5 being up here, now 17.5 is still next to moles down here. So that's why that turned into this. So moles cancel moles to give liters for the answer. And this divided by this gives that number. And remember, if you're given milliliters, you better respond in milliliters unless otherwise told, and it doesn't tell you otherwise. So we got to take this number and convert to milliliters. Remember, 1,000 milliliters to a liter, so liters cancel liters, and then that gives you this many milliliters, and that becomes the answer that you box. Again, I need to emphasize, it doesn't matter whether you do it this longer way, which doesn't really require to remember any calculation or any special formulas, or if you want to memorize M1 V1 equals M2 V2, and then do this way of doing it, where you do the formula, plug in numbers after you rearrange it, and get an answer. Either one is perfectly valid. All right, that should take care of that.